This is example number 11 from chapter 13, section 13.6. So we have a smooth can C that is lifted from this, with this rod from point A to point B. That rod is rotating, and is rotating actually with a 0.5 radians per second angular velocity, which is constant. And they want us to find the forces exerted in C when theta is 30 degrees. And we have also the expression how this R, which is from this point, let's call this O, to C varies, which is given by 1.2 cosine of theta meters. So the solution, the first step in our solution is to select the proper coordinate system. Since we are given an expression for R and we are given information about theta, we are going to choose the R and theta coordinate system. Cylindrical, components to find our forces. So the first thing we're going to do is draw our free body diagram of our particle. So they can see and which forces are exerted over the can. The first thing that we can never forget is the weight. So we know that the gravity is always vertical, right? And has a value of 9.81 meters over second squared. So we are going to draw our weight, and the weight will be the mass, which is 3 kilograms times 9.81, and that weight will be given in newtons, right, at the end. Then we have to draw our normal or reaction forces. So the particle C is in contact with two surfaces, right, because it's in contact with that rod. So we have a normal that is perpendicular to that rod. So if we draw our coordinate system to be radial and theta, right, we know that our normal will be perpendicular to that R. So we have a normal right here perpendicular N, which is perpendicular to the R coordinate system, or to the R axis. And then we have another force that has to be perpendicular to this surface. So this is not, actually this will be in this direction. So, and we have to find out which angle we have to put. So we have to find this angle. Let's call that angle phi. And then, so we will put here our other reaction, and we name that angle phi. So what would that angle be if we draw this little triangle here? So let's draw this triangle. This is R, this is theta, and this is theta. This angle, we are told to calculate everything for 30 degrees. And this is 600 millimeters, and this is also 600 millimeters. So if we split triangle in two, we see that those triangles are exactly the same. So this angle has to be 30 degrees as well. So those two triangles are exactly, so this phi is also 30 degrees. And this angle, as you see, since we are inclined 30 degrees in my bar, this is also 30 degrees. So we have two forces, and all of them are 30 degrees. So now we have to draw our kinetic diagram of our particle. So we will draw also our coordinate system. And then we have, in cylindrical components, we will have one acceleration, which is m, one force that is in the direction, which is my kinetic force will be the acceleration in r times the mass, and then we have another acceleration m times theta. We have to remember that r theta is, I don't pretend to you to learn this by heart, you will have that in your formula sheet. Is equals r2 dots minus r theta dot square. So, but we do have to find, in order to make those two free body diagram and the kinetic diagram equals, we have to find those acceleration, those components. So let's do that. Start with theta. We know that theta is equals to 30 degrees. Theta dot is equals to 0.5 radians over second. And we know that this is constant. So if it's constant, then we know that theta 2 dots is equals 0. Then we have the r. So r, we are given the expression 1.2 cosine of theta. For theta equals 30 degrees, this is 1.2 cosine of 30 theta, you know that is square root of 3 over 2, and that's equals to 1.039 meters. Then we have our dot. Our dot will be the derivative of this. This is 1.2 derivative of cosine is negative sine theta times the internal derivative, right? Because theta is a function of time, so we have to multiply by theta dot. And that's equals to 1.2 negative sine of 30 times theta dot, which is 0.5. And that's equals to negative 0.3 meters over second. And then we have theta 2 dots, which will be the derivative of this expression. And this is the multiplication of two functions, sine and theta. So we have to derive this, multiply by that one, and then derive that and multiply by that one. So that will be 1.2, the derivative of the first, times the internal derivative, times that one, so that gives me theta square plus, oh sorry, I didn't derive the sine, it's cosine, right? The derivative of sine is cosine, and then I write the first function sine theta, and it's a negative 2 here, times the derivative of the second function over time. So that will be 1.2, I can actually put the negative sign outside, cosine of 30 degrees times theta dot square, which will be 0.5 square, minus sine of 30 times theta 2 dots, and theta 2 dots is 0. And that, if we evaluate those, we get negative 2.598 meters over second square. We have r, we have theta 2 dots, which is 0. We have r dot, theta dot, r2 dots, and r, and so having all the components, we then apply equation of motion. Then we add forces in our r direction, right? Which will be equals to MAR, and that's it. So which forces do we have in r direction? So we have negative weight, and this is the component that we need. So it's sine of 30 plus r cosine of 30. And that's equals to MAR. So that will be equal, so let me plug in the values. That will be equals to the weight we say that is negative 3, 9.81. Sine of 30, we know that is 0.5. Plus r, which we are looking for, cosine of 30, we know that is square root of 3 over 2, is equal to the mass, which we know that is 3. And the value of r, we have to I haven't calculated that, but it's R2 dots, which is negative 2.598 minus R, which is 1.039 times theta dot square is 0.5 square. Okay, so if we plug all those numbers, we get that R is equals to 15.2 newtons. Please check all the calculations. And then if we add forces in theta, m theta, we got. What do we have in theta direction? So we have, in theta direction, we have the weight cosine, right? So, and it's a negative, that goes in the negative direction, y cosine of 30. Then we have a r sine theta, positive, plus r sine of 30 degrees, right? This is this component right here. And then we have n plus n, and that will be equals to m a theta. So if we plug all those numbers, we have negative 3 times 9.81 cosine of 30 is 3 over 2 plus r, we can actually plug that number that we got already. Sine of 30 is 0.5, and then plus n that we don't know how much it is, that's what we are looking for, times 3, and then we got theta, which is 2 times r dot is negative 0.3 times theta dot. Theta dot is 0.5. Please check all the numbers, and then we got that n is equals to 17.0 newtons. Well, it's very important, as you see, we have many variables, but that's not the hardest part of the problem. So don't get intimidated by all these problems. What is very important is for you to know how to do your free body diagram of both, find the right angles, and then you have to have the components correct, the sine and the cosine of each component, and of course calculate all the terms that involve the acceleration in the theta and the r direction. This is it for this example.